Hello everyone, I'm Amulya BR from Sri Venkateshwara College of Engineering and I belong to the branch CSE AI. So today I'm back with another video on the subject Automata Theory and Compiler Design and on the topic Pumping Lemma and its applications. So let us look into what we are going to learn today. The contents are Introduction to Pumping Lemma, Statement of the Pumping Lemma, Proof of the Pumping Lemma, Applications of Pumping Lemma in Formal Language, Usage of this lemma to prove language is not regular, Connection between Pumping Lemma and Turing machines, Real World Application and Relevance, Limitations and Challenges of Pumping Lemma, Criticism and Alternatives for Pumping Lemma, and its conclusion. So now let us see the introduction to pumping lemma. The pumping lemma is a fundamental concept in the theory of formal languages and automata, particularly in the context of regular languages. It is used to prove that certain languages are not regular, providing a tool for demonstrating the limitations of regular expression and finite automata. So the pumping lemma applies specifically to regular languages, which are the simplest class of formal languages. A regular language is commonly used to examine and analyze the properties and to prove the pumping lemma. Statement of the pumping lemma. So it goes like this. For every regular language L, there exists a constant P, that is the pumping length, such that any string S in L with length at least P can be divided into three parts, that is X, Y and Z, which satisfies the following conditions. So the first condition is for each I greater than or equal to 0, the string X, Y to the power I and Z is in L and the mod of y is greater than 0. So in simpler terms, the pumping lemma says that for any sufficiently long string in regular language, you can pump a part of it and still remain in the language. So it is a repeatable pattern which asserts that the factorization can be repeatedly pumped to produce additional strings that can still belong to the language. Now let us see the proof of the pumping lemma. So this can be proved by contradiction. The pumping lemma is often used as a proof technique. So to show that a language is not regular, you can assume it is regular, apply the pumping lemma and then find a string that does not satisfy this condition, so which leads to the contradiction. So this is called the method of contradiction proof. So in summary, the pumping lemma is a powerful tool which provides the non-regularity of certain languages. It helps to establish the limitations of regular languages and it serves as the foundation concept in the broader field of formal language theory. So it consideration of string length and then you need to identify the factorization and then repeatability of verification, and this can also be done through the contradiction method as I spoke earlier. So now let us see the applications of pumping lemma in formal language. So the pumping lemma contributes to the understanding of language hierarchy, which classifies the language into different levels of complexity. Regular languages, context-free languages, context-sensitive languages and recursively enumerable languages are the part of this language hierarchy, and the pumping lemma helps distinguish between them. So and then it helps in the compiler design. So in compiler theory, understanding the capabilities of regular languages is essential for lexical analysis. So the pumping lemma can help design efficient lexical analyzers and parsers for the programming languages, and then it helps in the algorithm development. So the understanding the limitations of regular languages is crucial in algorithm design. So for example, problems that involve pattern matching or the parsing languages may require more powerful tools than regular expressions if the languages are not regular. So those were the applications of the pumping lemma. Now moving forward, let us see the pumping lemma usage to prove the language is not regular. So this is done by selecting the target language, and then we need to apply the validations for condition, and then we should prove that the pumping inconsistency, and we should demonstrate it. So the primary application of pumping lemma is to prove that the specific languages are not regular. So this is often done through the method of contradiction. So this is assuming the language is regular, applying the pumping lemma, and then showing that there exists a string that violates the condition of the lemma. So as I told earlier, the statement goes like this: for every regular language L, there exists a constant P such that any string S in L with length at least P can be divided into three parts, that is X, Y and Z, which should satisfy the condition mod of Y should be greater than 0, and then the string xy to the power I z, it should be present in L. Another application of pumping lemma can be seen as the connection between the pumping lemma and the Turing machines. The most general type of grammar is unrestricted grammar. So this is a connection between pumping lemma and Turing machine. So the languages generated by unrestricted grammars are recognized by Turing machines. The pumping lemma for context-free languages is a specific case of more general pumping lemma that applies to unrestricted grammars. So there is a similarity that is existing between them. Some of the real world applications of pumping lemma are: it is used in software development. So it is used for the creation of language processors and parsers. As I told earlier, for lexical analysis it can be used, and then for data processing. So it is applied in analyzing and processing the data, especially in natural language processing tasks. And then it is used in big data analysis for identifying patterns and regularities within the data. Limitations and challenges of pumping lemma. So the first one is it is specific to regular languages. It cannot be directly applied to prove the non-regularity of context-free or context-sensitive or recursively enumerable languages. So it is only restricted to the regular languages. And then the second one is false positives. So which is, if a language fails the conditions of pumping lemma, it is not necessarily non-regular. So it fails there. And then not applicable to decision problems. This is the third one. It is less applicable to decision problems or questions about any specific strings. For example, it doesn't directly address questions like does the string belong to the language. So if this is a question, it does not address directly to these type of questions. So these are the limitations and challenges of pumping lemma. So now let us see the criticism and any alternatives that are present for the pumping lemma. So the first criticism is the variability. It does not account for languages with variable length constructs, which are commonly found in natural languages. So it only accounts for the fixed length constructs. And then the second critics is that effectiveness. Some critics argue that the lemma may not effectively handle non-regular languages, which leads to inaccuracies. And then alternative models. So newer models and theories have emerged which provides alternative approaches to analyzing the structure of formal languages. So now let us move on to the conclusion. So we can conclude by saying that its primary application is providing the certain languages are not regular through proof of contradiction. And then the pumping lemma is a fundamental concept that is taught in formal language theory courses, which serves as a tool for understanding the limitations of regular languages. And then in compiler theory, pumping lemma contributes to the design of efficient lexical analyzers for programming languages. And then while it indicates non-regularity, it does not provide constructive method for generating or recognizing the language. And then the foundational theorem. The lemma remains powerful foundation theorem which provides fundamental insights into regular languages and their properties. I thank each and everyone for watching the video completely till the end. I also request you to please like the video and share it amongst your friends. I ensure to come back with another video of different subject. Until then, have a good time. Thank you.